Hello everyone, I am Masood Ibn Abdul Wahid. Welcome to the second video of Arduino video series. In this series of videos, we are discussing the control of electrical loads using Arduino, and to mention, these are the different categories of control. So we have discussed the unconditional control and we have discussed the different types of conditional control. So in this, we have practiced the unconditional control of lamp and conditional control using LDR sensor. Now let us continue by taking the next sensor. So conditional on and off of an electrical lamp using IR sensor. So IR means infrared sensor. We are going to use the IR sensor, and in this IR sensor what you are seeing in the screen are both are of general purpose type. So just you have to note what is the pin configuration and connect accordingly. So just for information I am saying, we are going to use this IR receiver for today's video demonstration. So this is called to be TSOP 34833. So the different variants of IR sensor will vary in its carrier frequency. Actually, if you see, so this two numbers decides the carrier frequency of the IR receiver. So this is 33 kHz. We will start the video demonstration by taking this IR receiver. First, let us discuss about the Arduino code. So this is the code we are going to use for sensing the IR sensor output value. We have connected the IR sensor output to pin number 2, and we have declared this IR sensor output as the input for the Arduino microcontroller. For simultaneously seeing the output value in the serial monitor, we have begun the serial communication, and inside the loop function we have received the output value of the IR sensor and we stored it in a location called IR sensor value, and just we have printed this in the next line. The electrical lamp is here, and you can see that it is connected to the electrical supply through a relay module, and this is the breadboard, and that is the Arduino microcontroller. Now we are going to use this TSOP IR receiver. So the number of this is TSOP 34833. So fix it here. 5V pin of the Arduino, connect it in the breadboard. Take the ground pin of Arduino, connect it with the breadboard. Give the 5V input for the IR receiver and give the ground for the IR receiver. Let us connect the output of the IR receiver to pin number 2. There are two transmitters here. I'm going to use both the ones, and simultaneously you can see what is the output value. So before starting the control of electric loads using IR transmitter, let us check the IR transmitter is working or not. So this is the IR transmitter, so it is working. So this is how you need to check. So this infrared, we cannot see it in our eyes. We can open the camera and focus the IR into the camera vision. So when you press the button, you can see IR rays to be emitted. So after checking the transmitter, we can start applying our control. You can see the serial monitor value. The output pin of the IR sensor is at high value. So when I press the remote, it is giving a 0 value. So the moment I press, the IR sensor output goes low. So I am using another transmitter. See, the moment I press, it is giving a low output. So this low output signal is the one which we are going to utilize for controlling the lamp status. So let us take this code. In this, the lamp pin was selected to be 13 as usual. The IR sensor output in pin number 2, and we are going to declare these two pins. So the lamp is the output pin and the sensor input is going to be used for controlling the lamp, so it is declared as input pin, and we are going to simultaneously see the output of the IR sensor in the serial monitor. So we have begun the serial communication, and inside the loop function we received the IR sensor output value in terms of digital read. In the pin number 2, I am receiving the IR sensor output, and if I find the value to be 0, then I'm going to switch on the lamp, and if I find the value to be 1, I'm going to switch off the lamp. I have given low command for switching on and high command for switching off. So this is because the relay modules we are using is active low module. So let us do the connection. So now we are going to do the connections for utilizing the digital read value. So for that, so let us take the 5V line connected with the VCC of the relay module. Let us take the ground line and connect it with the ground line of the relay module. Pin number 13 is connected to the control input pin of the relay module. After finishing the connection, upload the corresponding program into the Arduino Uno board. So it says done uploading. So by default you can see here the IR sensor is giving the high output value. For that, according to the command, the lamp is in switch off condition. When we send some IR signal, you can see the lamp is switching on. So I am using another transmitter. So as I mentioned, it is a general purpose IR receiver. We can use any of our IR home remotes. It may be a AC remote, it may be a TV remote. So by this way, we can control the electric lamp using IR sensor. Some of the limitations which we will face in the IR transmitter and receiver cases. So we need to operate the transmitter and receiver in the line of sight. The transmitter should be in line, or it should be in the visibility of the receiver. Otherwise, the transmitted signal will not be captured by the receiver. So this is one of the limitation. To overcome this limitation, we can use the next level of wireless communication, which is through RF wave or Bluetooth communication, which we will discuss in the further videos. So the next category of control what we are going to discuss is the control of the same electrical lamp using PIR sensor, normally called as human motion sensor. Next, what we are going to see is conditional on and off of an electrical lamp using PIR sensor. PIR stands for passive infrared sensor. The another simple name for this sensor is motion sensor, because this sensor is used to find the human motion. So when the people are moving around, so this sensor will pick up that movement and it will be delivered to us through the output pin of the sensor. That sensed motion, we can use it for controlling our lamp. This is the PIR sensor, which is having 3 pins: VCC, in which you can give 5 to 12 volt, ground pin, and the third is the output pin. The output pin is rated for 3.3 volt TTL. So there will be 2 potentiometers available for us. One for varying the coverage distance, and this potentiometer is for time adjustment. After sensing a motion, how long the output pin should be high. And there are 2 modes of operation in this PIR sensor. One is single trigger and another is multi-trigger. You can fix between these 2 modes by fixing the jumper accordingly. So this is the PIR sensor and this is the bottom view. So you can see 3 pins, jumpers for selecting the single trigger mode and multi-trigger mode. And this is the potentiometer for varying the coverage distance, and this is the potentiometer for varying the time period. If you open the cover, you can see the pin configuration of the PIR sensor. So this is VCC and the last is ground. The middle one is the output pin. So let us do the connection for this. So this is the VCC pin, connect with the VCC line, and this is the ground pin, connect it with the ground line of the breadboard, and the middle is the output. You need to connect it in pin number 2. Connect the VCC of the relay module to the 5 volt line, and connect the ground of the relay module to the ground line, and connect the control pin of the relay module to pin number 13. Now all the connections are over. Now we will discuss about the Arduino coding to utilize this motion sensor for controlling the electrical lamp. So this is the coding we are going to use for controlling the electrical lamp using LDR sensor. So in the coding, you can see that we have declared the PIR sensor to be in pin number 2, and we are going to connect the lamp through relay module in pin number 13, and the PIR sensor will give the output, so we will receive it as the input in the Arduino. The lamp is going to be controlled, so it is the output. We have to declare the PIR to be input for the Arduino, and the lamp will be the output for the Arduino. And to simultaneously see the command lines, we have used the serial communication begin statement, and inside the loop function we are going to read the PIR sensor output value in digital terms. So digital read PIR, so that will be compared whether it is high or low, whether it is 0 or 1. If it is high 1, then it means motion is detected, so we need to switch on the lamp. If the PIR is giving a 0 output, then the lamp will be switched off as there is no motion. So when the motion is detected, the lamp will be switched on. You can see that in the serial monitor screen also. After the motion is detected, the on time period of this lamp can be controlled in the programming also, or you can control it in the PIR sensor's potentiometer also. When there is no motion, the lamp will be switched off. The distance covered by the PIR sensor also you can adjust to be from minimum to maximum value by adjusting the corresponding potentiometer. I hope you like the video. Subscribe the channel and click the bell icon for getting immediate notification, and share the video. Hoping to see you in the next video. Until then, I am Masood Ibn Abdul Wahid signing off.